I want you to just close your eyes for a second and imagine a smart city. Like, what do you actually see?
Usually it's something out of a movie. Right?
Yeah, exactly. If you're like most people, you're probably picturing this massive, gleaming metropolis, neon lights everywhere, maybe autonomous flying cars zipping between these giant skyscrapers.
Oh, definitely. Very cyberpunk.
Right. And the whole thing is usually run by a giant monolithic tech corporation that is silently collecting every single piece of data about your life. It's very top down and honestly a little bit intimidating.
Yeah, we've sort of just accepted this cinematic narrative, haven't we? That the future basically belongs to trillion-dollar tech conglomerates.
Exactly.
Like, they're the ones who will sell us our cities in these neatly packaged proprietary software updates.
Yeah.
The assumption is always that innovation only trickles down from a handful of server farms in Silicon Valley or Shenzhen.
And we just lease the infrastructure.
Right. We treat municipal infrastructure as something you just rent from a vendor rather than something a community actually builds and owns.
But today, we are going to pivot sharply away from that whole sci-fi movie trope, because a much more revolutionary version of the future is actually being built right now as we speak.
And it is not happening in a recognizable megacity.
No, it's not. It is happening in a municipality of about 73,000 people in the south of Brazil.
Which is just so fascinating because it turns the traditional model of technological adoption completely upside down.
It really does. So today's deep dive is based on a really fascinating research paper. It's titled, Building a Smart City That Stimulates Innovation Using Open Source and Decentralized Technologies.
It's quite a mouthful, but the team behind it is incredible.
Yeah, it's authored by this unique coalition. You've got researchers from Unijuí University in Brazil, the University of Cambridge in the UK, and, the municipal government of Santa Rosa itself.
A really rare collaboration.
So for you listening, I want to just set the stakes up front here. This isn't just a rundown of cool new gadgets and blinking antennas.
No, not at all.
We are exploring a radical shift in how we think about our data, our environment, and our local economies. Like, the goal today is to see how this one city is actively avoiding cloud monopolies, relying on decentralized tech, and proving that things like equality, diversity, and inclusion can actually be hardwired into a city's technological blueprint.
From the very beginning.
Exactly. Okay, let's unpack this, because before we look at the hardware, we really have to understand the geography and the philosophy driving this project. You simply cannot separate what they are building from where they are building it.
Right, because context determines design.
Yeah.
Technology doesn't just exist in a vacuum. It has to interface with the dirt, the weather, the economy, and the history of a specific location.
Yeah, so let's look at Santa Rosa. It was founded in 1931. It covers roughly 488 square kilometers, and the population is hovering right around 73,500.
It's a major industrial and commercial hub.
Right, and strategically located near the borders of Argentina and Paraguay.
And that geographical placement is really the engine of their entire strategy. When a city sits near international borders like that, you have a natural convergence of, trade routes, agricultural exchange, industrial logistics.
It's a massive crossroad.
Exactly. So the Santa Rosa City Council recognized that to harness that sheer volume of movement and commerce over the next couple of decades, they needed a 20-year vision.
20 years? That's a lot of foresight for a local government.
It really is. They decided to transform the municipality into the premier innovation hub of the south of Brazil by building a completely data-driven economy.
But the source material is very careful to clarify how they view this transformation. They don't see the city as just like a physical space to install a bunch of sensors.
No, they define Santa Rosa as a complex socio-technical system.
Right. And I know that sounds like heavy academic jargon.
It does a bit.
But my read on this is that they are actively rejecting the idea that technology alone fixes civic problems. Like, if you install an AI system to manage traffic lights, but you completely ignore the local economy, the trucking routes, and the social habits of the actual commuters,
the system will fail.
Exactly. It'll just fail.
You've hit the core of it there.
Yeah.
A socio-technical system demands that the technical dimensions, the economic realities, and the social impact are all balanced equally. You literally cannot upgrade the tech without upgrading the social infrastructure alongside it.
Which is where the Cambridge connection comes in.
Right. To enforce this balance, the project relies entirely on a methodology developed at the University of Cambridge, known as the DC2FC framework.
Digital Cities for Change, competency framework.
That's the one.
Yeah.
And the DC2FC framework is essentially a prophylactic against bad tech policy.
Okay, how so?
Well, it operates on a strict sequence: planning, testing, and embedding. It explicitly forbids indiscriminate full-scale deployment right out of the gate.
Oh, wow. So you can't just flip a switch.
Exactly. A traditional city might, sign a contract with a massive telecommunications company and suddenly bolt proprietary cameras and air quality monitors to every single streetlight in a matter of months.
Which happens all the time.
All the time. But the Cambridge Framework argues that this just creates isolated silos of technology that don't actually serve the public. Instead, it demands that every piece of technology generate measurable public value.
Okay, so buying a corporate smart city package from a massive tech conglomerate, it feels like buying a pre-furnished mansion where the developer explicitly forbids you from rearranging the furniture.
That's a great way to put it.
Like you get what you get, and you have to adapt your daily life to fit a floor plan that some boardroom decided on thousands of miles away.
Right, you're fitting into their mold.
But Santa Rosa, instead, seems to be building the house brick by brick. Like they are pouring the foundation to fit the specific family that is actually living inside it.
And the researchers actually went in and conducted exhaustive interviews with 3 core members of the Santa Rosa development team, specifically to assess their compliance with this Cambridge framework.
They were testing the government itself.
Yeah. They needed to identify any competency gaps, places where the city's ambition maybe outpaced their technical or social readiness before a single wire was even laid down.
I do have to push back gently here, though.
Sure, go ahead.
We are talking about an incredibly complex, slow-moving academic framework developed at Cambridge University. Isn't a municipality of 73,000 people a little too small to test a global blueprint for a smart city?
I see where you're going with this.
Right. Because if you want to prove a system works for the future of human urbanization, shouldn't you be testing this in, I don't know, London or São Paulo?
What's fascinating here is that the manageable scale is the exact reason this is actually working. Yeah. Megacities are practically unsteerable shifts. If you attempt to test a radically new decentralized open source framework in a city of 12 million people, the bureaucratic inertia alone will kill the project.
Oh, the red tape would be a nightmare.
Exactly. You have centuries of legacy infrastructure, competing political fiefdoms, tangled corporate contracts. But in Santa Rosa, the scale acts as a perfect socio-technical laboratory.
So it's small enough to manage.
Right. You can introduce a variable, say a new environmental sensor in a specific neighborhood, and actually measure the social and economic ripples it creates. You can fail safely, iterate quickly, and then embed the successful technology deeply into the community.
Okay, so the scale is the feature, not the bug.
Precisely.
That leads directly to the question of execution then. If they are building this custom open source infrastructure brick by brick, where is the mortar actually being mixed?
Ah, the laboratory.
Right. The source material details the physical location where all this theory is transformed into reality. They call it the SmartLive Lab.
The engine room of the entire 20-year vision.
Yeah. So in 2021, the City Council partnered with Unijuí University's Applied Computing Research Group. They call them GCA.
Right.
They put together a joint proposal and successfully secured a grant of 1.3 million reais from the State Secretary of Innovation, Science, and Technology. And they used that funding to physically construct the SmartLive Lab right on the university campus.
Securing state-level funding like that is a massive validation of their socio-technical approach. The state government recognized that this bottom-up methodology might yield way better results than top-down corporate contracts.
It's a big vote of confidence.
It is. And the SmartLive Lab is designed explicitly to fulfill that testing phase mandated by the DC2FC framework. It allows the researchers to simulate real-life urban and rural conditions at a microscale before anything is embedded into the actual city grid.
And it serves a dual purpose, too. It's not just a testing ground, it's an educational pipeline.
Yes, the student involvement is huge.
The lab operates as a knowledge generator for undergraduate, master's, and PhD students. They even bring in international students. I mean, they are literally training the next generation of software engineers and urban planners on the very infrastructure that will eventually run their own city.
They are growing the talent locally instead of importing it.
Which creates this profound sense of civic ownership.
Exactly. When the citizens are the ones actually writing the code and welding the sensor housings, the technology is no longer some alien imposition. It's theirs.
So the lab focuses on 3 specific overlapping projects. The first is a 36-month initiative targeting economic sustainability.
Right.
The core objective there is investigating open-source, decentralized technologies to run digital municipal services. But the second project, this is another 36-month project centered on environmental sustainability. When I read this section, I actually had to pause.
The biodegradable sensors.
Yes. They are manufacturing and testing biodegradable sensors directly in the lab.
That is a staggering departure from industry norms. I mean, nobody does that.
So what does this actually mean? Because we talk constantly about green tech, but there is this massive unspoken paradox in the smart city industry.
The e-waste problem.
Exactly. If you want to monitor the environmental health of a city, you have to drop tens of thousands of sensors into the soil, into the waterways, and across all these industrial zones.
Right.
Over the span of a few decades, those lithium-ion batteries and plastic casings are going to degrade. So we are essentially fighting pollution by creating this slow-motion avalanche of electronic waste.
It's a huge contradiction. A standard smart city sensor relies on rare earth metals, synthetic polymers, toxic battery chemicals. When a sensor deployed out in some massive agricultural field reaches the end of its life, retrieving it is often economically unfeasible.
Nobody's going out to dig up a $5 plastic sensor.
Exactly. It just stays there, becomes poison. By researching and fabricating biodegradable sensors, the Santa Rosa team is fundamentally realigning the hardware lifecycle with the biological lifecycle of the region itself.
Oh, that's brilliant.
The tool used to monitor the ecosystem eventually dissolves back into it safely.
It's the ultimate expression of the public value requirement.
Totally.
And then we have the third pillar of the lab. This is a 24-month project focused on connected places. The stated goal here is to integrate the rural farming areas with the urban smart infrastructure.
If we connect this to the bigger picture, this third project exposes the glaring blind spot in almost every other smart city initiative on the planet.
Which is?
Historically, the intelligence of a smart city basically terminates at the city limits. The data collection stops where the concrete stops.
Oh, right.
The surrounding agricultural periphery is treated as a dead zone, technologically speaking.
Which is just economic madness, considering how deeply an agricultural hub impacts the commercial downtown. Like, if a blight wipes out a crop just outside city limits, the warehouses inside the city empty out, the trucking companies lose contracts, and the local economy just tanks. You can't separate the two.
You really can't. The Santa Rosa project treats the urban core and the agricultural periphery as a single symbiotic organism. The health of the soybean fields is just as critical to the data ecosystem as the flow of traffic in the commercial district.
Okay, so with the philosophy in the laboratory established, we need to actually look under the hood at the gear.
Let's get into the hardware.
How do you physically build a decentralized nervous system for a municipality spanning nearly 500 square kilometers? The paper lists the exact hardware specs, and it's fascinating.
It strips away all the corporate magic and just shows you the nuts and bolts of a municipal data network.
Yeah. So they are relying on a backbone of 26 LoRa Outdoor 8 dBi Omni antennas, and these are operating on the 915 to 923 megahertz frequency range.
Okay, for the listener who might not be a network engineer, LoRa stands for long range.
Okay.
Think of your standard home Wi-Fi like someone shining a massive, bright spotlight inside a single room. It carries a tremendous amount of data. You can stream 4K video seamlessly, but the moment you step outside or put a thick wall in the way, the signal just dies.
Right, the range is terrible.
Exactly. Now, LoRa, operating at that lower 915 megahertz frequency, is entirely different. It's more like the low rhythmic thumping of a bass drum from a concert 3 miles away.
Oh, I like that analogy.
It doesn't carry a lot of complex data. You couldn't send a high-resolution photo over a LoRa network, but that low-frequency radio wave can penetrate concrete buildings, dense forests, and heavy rain across a massive 10-kilometer radius.
Wow, 10 kilometers from one antenna.
Yes. And crucially, it requires almost zero power. A sensor sitting out in the field can run on a battery the size of a coin for years, just quietly pinging tiny packets of text data to those antennas.
That's incredible. So to interface with those antennas, the lab currently has an arsenal of 260 specialized sensors ready for deployment.
Quite a stockpile.
Yeah, the paper breaks the inventory down specifically. They are using 40 temperature and humidity sensors, the RAK 1901 WizBlock models. They have 40 ultrasonic ambient light sensors, 40 noise sensors, 10 water level monitors, 20 ultrasonic MQ3 gas sensors, and 40 sensors dedicated to continuously assessing water pH levels.
That's a huge variety.
Plus, they maintain an array of 3D printing and prototyping modules right there in the lab to build whatever else they need.
Notice how they aren't just measuring weather. They are capturing the acoustic and chemical footprint of the entire municipality.
Right.
The ultrasonic noise sensors, for instance, they don't just record audio. They map out decibel identify, say, traffic congestion patterns or even illegal industrial operations in real time.
Like tracking noise pollution spikes.
Exactly.
Yeah.
And the MQ3 gas sensors can detect alcohol, ethanol, smoke, giving them a real-time heat map of air quality degradation.
But all of those hundreds of thousands of data points have to be routed somewhere to be analyzed, right?
They need a brain.
Right. And the brains of this entire operation is surprisingly humble. They aren't renting space on some massive Amazon server farm. They are running a physical Dell computer locally.
Just a standard machine?
Yeah, equipped with 256 gigabytes of RAM and 2 terabytes of storage. It runs a Linux operating system and hosts the open-source TripStack network server.
I have to say, the decision to run a local Linux machine rather than defaulting to AWS or Google Cloud is perhaps the most politically and technologically significant choice outlined in this entire paper.
Oh, absolutely. The authors do not mince words here. They state explicitly that their strategy deliberately avoids purchasing from cloud monopolies.
They are very clear about that.
Yeah, they argue that these massive tech conglomerates generate their insane profit margins by abusing their business power and market dominance rather than through genuine innovation.
And to combat that centralization, Santa Rosa relies on P2P, or peer-to-peer interaction models.
How does that differ from the norm?
Well, in a traditional client-server model, which is what you use when you log into almost any cloud service, all the data flows to a central point controlled by the corporation and then back down to the user.
A massive bottleneck.
Right, and a control point. In a peer-to-peer model, the nodes communicate directly with each other without a centralized middleman. The researchers are actually benchmarking these decentralized options right now. Like what they mentioned, comparing the decentralized social protocol Blue Sky against X or the open source communication protocol Matrix against WhatsApp.
The philosophy driving all this is summarized in one specific line from the paper that I just couldn't stop thinking about.
Which line?
The researchers assert that data is an asset, and to help innovation, it should flow like money.
Flow like money. That's powerful.
They argue that if data remains static, just hoarded in the proprietary silos of a few massive companies, local innovation stagnates. They want to construct a data-sharing infrastructure that operates exactly like a public road system.
That makes perfect sense.
The role of the city council is to regulate the flow of traffic, ensure the roads are paved, and enforce the speed limits. But the city does not own the cars, and they do not own the destinations.
It fundamentally redefines civic governance for the digital age. The municipality provides the secure highway, allowing citizens, universities, and small businesses to basically build their own applications on top of that public infrastructure.
Now, here's where it gets really interesting, and I have to play devil's advocate for a second.
All right, hit me.
If I am the mayor of a city and I want to digitize my infrastructure, isn't it infinitely easier, faster, and cheaper in the short term to just hand a blank check to Amazon Web Services or Microsoft Azure?
Oh, without a doubt.
Right. Why take on the massive operational headache of building custom Linux servers, writing own sensor housings, and managing your own radio network? It feels like choosing the path of maximum resistance.
It absolutely requires more upfront labor and technical expertise.
Oh.
But the researchers are playing a much longer game here.
Okay, explain that.
When a city hands its entire digital nervous system over to a single cloud provider, they willingly enter a state of vendor lock-in.
Ah, right.
If that corporation decides to, say, triple their subscription fees in 5 years, what does the city do?
Yeah.
They can't rip out the infrastructure. If the corporation unilaterally decides to discontinue a specific software product the city relies on, the city is paralyzed.
They're held hostage, basically.
Exactly. Or worse, if the corporation changes its terms of service and begins monetizing the citizens' data, the local government has zero leverage to stop it.
Think of a standard cloud server, like a commercial airline flight. Every citizen has to go to one massive, privately owned airport, board the exact same plane, and blindly trust the airline with their luggage.
I like that.
What Santa Rosa is building is more like a massive coordinated carpool network. If one car breaks down or one driver changes their route, the system doesn't collapse. The passengers just route through another node. There is no single point of failure and no single point of corporate control.
And avoiding that vendor lock-in is the only way a city can guarantee open governance. When the municipality controls the physical servers and the open source code, they can implement security and privacy protocols on their own terms.
And the paper actually details some heavy-hitting cryptographic technology they are exploring to ensure that privacy. They aren't just relying on goodwill here, they are building privacy directly into the architecture.
Yeah, they have to.
They discuss implementing decentralized digital identity systems, specifically mentioning Trust Chain, which was developed by the Alan Turing Institute.
Right. Trust Chain is essentially a framework for creating tamper-proof digital identities that don't rely on a central database.
So no giant honeypot of passwords to hack.
Exactly. It allows a citizen to prove they have the right to access a certain municipal service without revealing unnecessary personal information.
They are also integrating Key's privacy-enhancing technologies. The source lists AWS Nitro and Morello boards. Now, I know AWS Nitro is technically an Amazon product, but it's used to create highly secure, isolated enclaves where data can be processed without even the system administrator being able to see it.
It's like a black box for processing.
Right. And Morello boards are an experimental hardware architecture developed by ARM that fundamentally changes how computer memory is accessed. It practically eliminates entire categories of security vulnerabilities at the physical hardware level.
The inclusion of technologies like Trust Chain and Morello boards proves that this isn't just some scrappy amateur science fair project.
Not at all.
They are deploying military-grade cybersecurity protocols because they understand that an open-source public utility will constantly be targeted by malicious actors.
Okay, so we have established the theoretical framework, the anti-monopoly philosophy, and the impressive hardware arsenal sitting in the SmartLive Lab. But a smart city has to actually interact with the physical world. Let's move out of the lab and look at what happens when Santa Rosa officially turns this system on.
This represents that critical transition into the embedding phase of the DC2FC framework, where the technology starts interacting with the actual messiness of daily life.
Currently, the paper notes they have 12 LoRa antennas fully deployed. 9 of those are blanketing the urban space, and 3 are positioned out in the rural farming sectors.
And because of that 10-kilometer radius we discussed earlier, those 12 antennas are capturing a massive geographic footprint.
It creates this invisible canopy of connectivity over both the concrete and the soil.
It really does.
Underneath that canopy, they have installed 2 LoRa-based meteorological stations right in the urban center. These stations are constantly pulling metrics on air quality, wind velocity, luminosity, ambient temperature, humidity, noise pollution, and UV radiation levels.
A constant stream of local weather data.
And simultaneously, out in the rural deployments, specialized sensors are continuously monitoring the temperature and humidity of the soil itself, along with localized air properties.
And this is just the vanguard. The paper details their immediate expansion roadmap, which includes deploying 14 additional antennas and 10 more meteorological stations.
That's a lot of hardware.
It is. Their stated objective is to achieve 100% coverage of the entire municipality by 2025.
The sheer volume of data this produces is staggering. Since they initiated the collection process in August 2023, the system has logged and stored over 410,275 individual entries as historical series data.
Nearly 500,000 data points.
Yeah. But the power isn't in the hoarding of the data, it's in the distribution. Because they view this as a public road system, the data is open. They share it with academic researchers, with local supply chain companies, and directly with the agricultural sector.
And the real-world applications they highlight in the paper are incredible. They really demonstrate how a single agnostic data layer can serve wildly different industries simultaneously.
For example, local logistics companies are dropping cheap sensors into their warehouses. They use the city's public LoRa antennas to ping inventory levels, warehouse temperature, and humidity data back to their own local servers.
So they don't have to build their own network.
Exactly. And out in the rural zones, fish farmers have placed continuous monitors in their aquaculture tanks, using the exact same public infrastructure to transmit water quality and pH metrics.
Aquaculture is incredibly volatile. I mean, a sudden spike in ammonia levels or a drop in dissolved oxygen can wipe out an entire harvest in hours.
Just a total loss.
Yeah. So continuous low-cost monitoring isn't just a convenience for those farmers, it is absolute risk mitigation.
But the example that really stopped me in my tracks involves the soybean industry.
Oh, this part is fascinating.
Soybeans are a massive part of the regional economy. The researchers developed a system that analyzes the continuous stream of soil, humidity, and temperature data to predict the likelihood of an outbreak of Asian rust.
Asian rust is a highly aggressive fungal disease. It's caused by the pathogen like Phacops pachirizi.
Did I pronounce that right?
Close enough. But it causes rapid defoliation of the soybean plant. It prevents the pods from selling out, and it can literally obliterate up to 80% of a crop's yield if left unchecked.
That's devastating. And the fungus thrives under very specific microclimatic conditions, right? Specifically, prolonged periods of high humidity and moderate temperatures.
Right.
Because the city has sensors physically in the fields, the moment those precise conditions are met, the public infrastructure automatically notifies the farmers.
Real-time alerts.
Yeah. They can apply targeted fungicides preemptively rather than spraying blindly or waiting until the crop is already infected. The city is literally using public data to actively defend its own agricultural GDP.
And that precise predictive capability is exactly why they want to deploy those 10 additional weather stations. They want to map the microclimates.
Because weather varies so much locally.
Exactly. The weather at a farm on the valley floor might be radically different from a farm 3 kilometers away up on a ridge. Granular data replaces guesswork.
And it isn't just supply chains in agriculture. The public health services in Santa Rosa are using this same LoRa network to deploy home and body sensors to remotely monitor the vital signs of the elderly population.
That's amazing.
Just pause and think about the diversity of that ecosystem. You have soybean fungal predictions, warehouse logistics, fish tank pH levels, and a grandmother's heart rate all transmitting simultaneously across the exact same open-source public utility.
Which raises a really important question.
What's that?
How does a small municipal team possibly manage a network with that level of chaotic diversity? The data flow is entirely asynchronous and unpredictable.
It must be a logistical nightmare.
The researchers explain that to handle this immense optimization problem, they employ search-based software engineering, or SBSE.
Let's break that down because SBSE sounds intimidating. How does it function in this specific context?
Okay, imagine you are given a limited budget to purchase 14 new antennas, and you need to mathematically optimize their physical placement across 488 square kilometers of varying terrain. You've got hills, dense urban buildings, open fields.
You want to maximize coverage but minimize overlap.
Exactly. A human engineer can spend months calculating line-of-sight logistics. SBSE algorithms approach this as an optimization problem. They run millions of simulations, slightly mutating the antenna placements in a digital twin of the city.
Mutating them.
Yeah, they evaluate the coverage, keep the best results, and then mutate those again. It basically uses evolutionary algorithms to find the mathematically perfect deployment strategy.
So it's essentially using artificial evolution to design the network architecture.
Exactly. Furthermore, because the entire system relies on decentralized, peer-to-peer communication, the software governing it must be highly self-adaptive. It utilizes runtime control loops.
Meaning it fixes itself.
Essentially, yes.
Yeah.
If a physical antenna gets struck by lightning and goes offline, or if a warehouse suddenly floods the network with thousands of sensor pings, a human operator isn't sitting at a desk frantically rerouting traffic.
The system just handles it.
Right. The network recognizes the anomaly and dynamically self-organizes, rerouting the data packets through active nodes to maintain the flow. It acts as an autonomous, self-healing nervous system.
Which brings us into the most profound section of our deep dive. When you pull the lens back and observe this self-healing network touching the lives of the elderly, the fish farmers, and the university students, you realize that the technology is ultimately just a scaffolding for the human element.
Because the socio-technical framework demands that you evaluate the human impact.
Right. The paper is incredibly explicit about the fact that equality, diversity, and inclusion EDI was not an afterthought or some corporate mandate added at the end. It was baked into the foundation from day one.
It's structural.
Exactly. The Santa Rosa region is historically diverse, serving as home to more than 20 different ethnicities. The research team at Unijuí University purposefully reflects this demographic reality. The core team consists of 7 female and 8 male PhD students.
The demographic composition of the engineering team is absolutely critical here. The paper emphasizes that the team includes individuals from ethnic minorities and from historically neglected regions of Brazil.
Which is so important.
It is. The traditional Silicon Valley model often relies on a highly homogeneous group of engineers who share similar socioeconomic backgrounds, and that inevitably leads to blind spots in how technology serves diverse populations.
Like, if you only have tech executives designing a smart city, the city will only serve the needs of tech executives.
Exactly. By ensuring the builders reflect the community, Santa Rosa guarantees that the tools they build will actually solve community problems.
Now, the researchers are commendably transparent about the fact that this is an ongoing process. The paper outlines several significant pending tasks. For one, they are currently building a comprehensive web portal and open APIs.
To make the data accessible.
Right. The goal is to allow any citizen or local developer to easily query the environmental sensor data or upload their own civic data sets.
They are also committed to releasing all of their internal Python scripts, their data dashboards, and their record management systems under open source licenses.
Which is huge for other cities.
Oh, massive. Any municipality in the world, whether in Kenya, India, or the United States, will be able to download Santa Rosa's architectural blueprint for free and adapt it to their own city.
And they are continuing to refine that decentralized digital identity system we discuss to ensure all of this public interaction remains highly secure. But we need to discuss the major overarching challenge they are currently facing. Because it is not a software bug or a hardware failure, it is a mystery with profound life-or-death implications for the region.
This is where the narrative shifts from an interesting technological experiment to absolute civic urgency.
According to the municipal health data, Santa Rosa exhibits a remarkably high incidence of cancer compared to the national average in Brazil.
It's an epidemiological anomaly that the local government desperately needs to understand.
The researchers at Unijuí want to unleash the full power of their socio-technical infrastructure to solve this. They want to apply advanced data-centric applications, like artificial intelligence and deep machine learning, to cross-reference the city's medical records with the massive troves of environmental data they are collecting.
Looking for patterns.
Exactly. They want to look for correlations between cancer clusters and soil toxicity, drinking water pH, localized air quality, genetic markers, dietary habits.
But they are slamming into a massive structural wall, known in data science as the silo problem.
So, when the paper describes the silo problem regarding the medical data, my understanding is that the hospital servers are literally walled off from the city's environmental servers.
Yes.
Like, the AI cannot connect a sudden spike in industrial air pollution to a spike in oncology appointments because the two databases don't speak the same language and they're legally isolated from one another. Is that the bottleneck?
That is precisely the bottleneck. Currently, the medical data in Santa Rosa is trapped inside two entirely separate, isolated repositories owned by the Municipal Medical Service.
And AI needs everything together.
Right. An AI model requires massive integrated data sets to find subtle, non-obvious correlations. If the medical data cannot communicate securely with the environmental data, the AI is effectively blind in one eye.
So how do they fix it?
Well, the researchers are urgently trying to establish the legal frameworks and the cryptographic mechanisms to break down these silos so the data can be merged without exposing any patient's personally identifiable information.
And this completely validates their absolute obsession with privacy-enhancing technologies.
It really does.
If your smart city is governed by a profit-driven cloud monopoly, citizens and hospital administrators are naturally going to refuse to share sensitive oncology records. No one wants an advertising conglomerate analyzing their community's cancer data to serve them targeted pharmaceutical ads.
The lack of trust entirely prevents the solution.
Exactly. But because Santa Rosa is building an infrastructure governed as a decentralized public good, where privacy is guaranteed by open source cryptography and managed by local stakeholders, they have a genuine opportunity to generate that trust.
Trust is the ultimate currency of a smart city.
It is.
You can have the most advanced LoRaWan antennas and the most sophisticated SBSE algorithms in the world, but if the public believes their data will be exploited, they will simply opt out.
But if they can safely break down those data silos, they might actually be able to identify the environmental trigger causing this regional cancer crisis. The stakes are just monumental.
The ultimate success of the DC2FC framework in Santa Rosa won't be measured by whether it makes warehouse logistics 10% more efficient. It will be measured by whether an open-source socio-technical system can cultivate enough public trust to deploy data that actually saves human lives.
So what does this all mean for you and me? We've covered a staggering amount of ground today in this deep dive.
We really have.
We've explored a municipality in the south of Brazil that is quietly dismantling the cyberpunk dystopia and building a radically different future. We went inside the 1.3 million Reyes SmartLive Lab, where students are literally 3D printing compostable, biodegradable sensors to eliminate electronic waste.
We examine the physical mechanics of a truly decentralized network using low-frequency LoRa radio waves to cast a 10-kilometer safety net over both commercial streets and rural soybean fields.
We saw how an open-source infrastructure running on a local Linux machine to actively starve out cloud monopolies is currently monitoring everything from fish tank chemistry and agricultural fungal threats to the daily vital signs of the elderly. Santa Rosa is proving with hard data that a city can fiercely own its technological destiny.
They view their data not as a commodity to be sold, but as a vital public resource to be protected, regulated, and utilized to solve incredibly complex human problems.
Which leaves us with a final thought for you to mull over as you go about your day. If you live in a city like London, New York, or Tokyo, you do not own your data.
Not at all.
You generate thousands of highly valuable data points just walking to the grocery store, and those points are instantly siphoned off to private servers. But if a municipality of 73,000 people in southern Brazil can build a sovereign open-source infrastructure that treats data as a public highway and use it to tackle everything from supply chain logistics to a regional cancer anomaly, what exactly is stopping the world's megacities from doing the exact same thing?
That's the real question.
Will the smart cities of our future be handed down to us in closed proprietary boxes by tech conglomerates, or will they be built from the dirt up, open and free, by local students and citizens? Keep questioning the world around you. We'll catch you on the next deep dive.